Hello friends, today I will discuss how to solve the linear programming problem by simplex method. This method can solve linear programming problems having more than two decision variables. The simplex technique involves generating a series of solutions in tabular form called tabulas. By inspecting the net evolution row of each tabula, one can immediately tell if it represents the optimal solution. Now I will explain the working procedure of simplex method. In the first step, initialization. First, we transform all the constants to equality by introducing slack, surplus and artificial variables. Here, less than equal to type constant, we will introduce the positive slack variable, and greater than equal to type, we will introduce the negative surplus variable plus artificial. Equal to type, so we will introduce the artificial variable, positive artificial variable. So to solve this type of problem, we first construct the initial simplex tabulas. So this is the pattern of the simplex tabulas. So first row Cj will indicate the all cost of the decision variable, slack variable and artificial variable. And here this column will indicate the cost of the basic variable. This is the basic variable, this is the basic feasible solution, and here is the all decision variable, slack variable and artificial variable. And there is indicate the coefficient of this constant, and here will be calculated the Cj minus Zg. So Cj minus Zg is basically net evaluation for the test of optimality. Zg will be calculated by summation of Cv into Xij. If all Cj minus Zg less than equal to 0, then the initial basic feasible solution is optimal. If any one of Cj minus Zg is positive, then the correct feasible solution is not optimal and proceed to the next step. In the first iteration, first we identify the incoming variable. If there is more than one positive value in the Cj minus Zg row, largest positive value is selected and corresponding variable is incoming variable. After that, we identify the outgoing variable. How to identify? We calculate the ratio. Ratio will be calculated by xb divided by xj. Xj is the incoming variable. Here is the minimum positive ratio we are selecting, and its corresponding variable is the outgoing variable. Here is one example maximization problem. Z is equal to 3x1 plus 5x2 and x1 less than equal to 4. So all constants are less than equal to type. So that's why we are introducing the slack variable S1, S2, S3, and all variables should be positive, non-negative. To calculate the initial basic feasible solution, we are putting 0 at a decision variable. X1 is equal to 0, X2 is equal to 0. So initial basic feasible solution is S1 is equal to 4, S2 12 and S3 18. So Z is 0. So now we are applying the iteration for the better solution. So this is the first initial tabulars, and this is the basic feasible solution Cj minus Zj. We are calculating here. Here 3 is positive, 5 is positive, 5 is largest positive. So this row column we are taking. So x2 is incoming variable, and now we are calculate the ratio xb divided by x2. So minimum ratio is 6. So corresponding S2 variable S2 is the outgoing variable. So its intersection point 2 is the key element. Now next table, this element should be 1, and other in this column other element should be 0. Here looking this, here 1 and 0, 0, 0. In such a way, we are completing this table Cj minus, again we are calculating Cj minus Zg. Here 3 is positive, so its corresponding variable x1 is the incoming variable, and now we calculate the ratio. So outgoing variable is x2. Okay, so now intersection point is 3. Okay, now next table, these 3 will be 1, and here is the 0 and 0. Now look at this table. 1, here is 1, here is 0 and 0 and 0. And how to calculate this 1? Actually, we divide this row by, all elements will be divided by 3. That's why it will be 1. Now 6 by 3 is 2, 3 by 3 is 1, and this way, and other is row operation will be used here to complete this table. And in the end table, here is all are 0 and negative. So optimality condition is satisfied. All Cj minus Zg less than equal to 0. So optimal solution obtained. So optimal solution is x1 is equal to 2, x2 is equal to 6, and z is equal to 3 into 2 plus 5 into 6 is equal to 36. So this is our solution. Thank you.